I'm a boat builder from the Cotswolds in the UK, and I'm currently building a boat called Temptress, designed by Michelle Berrier and kitted by myself to be built utilising the latest in CAD design, CNC cutting and modern epoxy wood construction. In this video we are continuing the epoxy coating process, doing the big bulkhead for frame 9 and some more frames as well. And I'm going to actually talk you through the process and what we do in that, so cleaning up the frame before epoxy coating. Also getting a big timber delivery from Sykes, so we've got all the timber coming in for the planking stock, for the internal and external planking for the boat. I'm going to talk a little bit about the actual epoxy coating process, why we do it. We'll look at a few of the things that you need to consider within that process as well with regards to the actual application of it, but also the environment and kind of things to consider before that encapsulation process begins. So let's get cracking. First of all, we're unloading the new timber delivery. So we've got another timber delivery coming in from Sykes Timber, and it's a big one this time. This is all of the planking stock for Temptress. So we've got a really nice selection of timber here. Beautiful, clean timber, as always, as we get from Sykes Timber. Massively appreciate Sykes Timber for supporting me with this project and helping to reduce my bill for the wood for Temptress, because it's quite a heavy bill, this one, and otherwise that would be a lot more painful. So thank you very much indeed, guys, for that. So we unloaded all the timber by hand. We've got a combination of things here. I'll take a look through this a little bit later on in the video, but we've got some sawn yellow cedar, which is going to form the internal planking on the bottom and the sides of Temptress. We've then got some sawn utility, which is going to form the outer planking on the bottom of Temptress. And then I've got some special boards that I've had sawn in half, which I'm going to use to create the side planking, which is going to be book matched. So the plan is to cut the planks out and then we'll resaw the boards afterwards, so we get a perfect match pair of every plank for the side of the boat. And Sykes have sawn all of that to the correct dimension for me, so we'll take a look through that a little bit later on and see exactly what we've got. Right now I can tell you the workshop smells incredible because of all of that sawn yellow cedar. It's a really nice smell to it. So I'm continuing with the epoxy coating process that involves pulling parts out of the boat one at a time, prepping them, cleaning them up, and then epoxy coating them before they can go back into place and be permanently bonded in. So the main focus of that right now are all the ring frames. So those are complete frames that have got a full deck beam over them. The reason for that is that these have got to be threaded onto the stringers, so they can't be loaded in and out as the open frames can. You can see me taking those out of place here. Those are nice and easy just to drop in over the stringer notches, but the ring frames have got to be threaded in. So that's frame 3, 4 and frame 9 as well. And then there's one back aft, but I can thread that in over the top of the transom. As you can see, there's a lot of contemplating that goes into this project. So before those parts come out, I need to just put a little stop block in place, and this just is going to help me to make sure that when these parts go back in, they're perfectly aligned and they're correctly positioned, because we did a lot of work previously making sure that we got everything straight and fair here, so we want to make sure that that goes back as it was post-coating. So that little stop block goes in just to re-reference the top edge of the bulkhead on frame 9, and then that can be unscrewed and removed from the legs. Take that out of the assembly, and then I can start to prep the bulkhead on the bench. So the alignment holes that help me to position everything within the boat on the frame construction table and also locate it on the CNC machine have to be plugged, and that's what you can see me doing here. I made some tapered plugs for this, and we'll take a look at those in just a minute. Now my gluing procedure for this is to have a little pot of West System epoxy, slightly thickened with their low density filler. You can see I dip the plug into that mix, and then what I do is wipe the bottom of the plug off on the edge of the cup. What this does is it creates a ring of adhesive around the outside of the plug, but not a big ball of it on the end. This is necessary, particularly when you're plugging closed bottom holes. If you've got a big ball of adhesive on the end of the plug, as you tap that plug in, that adhesive is basically going to form a lot of hydraulic pressure, and it's actually going to push the bung back out the hole if you're not careful. So that's the reason that I always glue up plugs in that way. Now, some of this footage you'll have seen bits of previously, slightly different clips, but the process for prepping the frames is basically all the same throughout the boat. So what I'm doing here is just using a small roundover bit, I think it's a 5mm roundover, in my little battery handheld router, which is great for just doing little trimming jobs like this. So we just want to put a radius on any edge that's going to be exposed within the boat. A couple of reasons for that really. We don't want any sharp edges to be on show, to catch yourself on when you're crawling around in the boat another day. But mostly really for finishing. We don't want any sharp corners for finishing. We're going to encapsulate everything within this boat with epoxy, and having a slight radius to that corner is going to allow us to do that thoroughly without the risk of breaking through in any corners. Finishing with all round edges just makes things nice and easy in that respect. So every edge that is going to be exposed within the finished boat needs to be radiused, and that includes all the internal faces of the frames except for where they've got parts to be bonded to them later on. And that also means on the outside of the framing as well. So you can see here that I'm rounding off the sections where those topside battens run through. There's little bits of timber frame in between those, and those need to be rounded because although they're up against the side of the boat, they don't actually touch the side of the boat. This is going to be gapped, and the whole planking will not land directly onto the frame. So we want that rounded off nicely so that we can have a good finished edge there, and we'll epoxy coat that in a bit. Now, this was making the plugs. I was looking around, shopping around for tools to try and create the plug that I needed for this. I need quite a specific plug for this particular operation. It needs to be a long plug, and it needs to ideally taper from 9.5mm to 10.5mm. I was looking around for a plug cutter, and then I realized actually I've got a CNC machine sitting there, so I quickly modeled up some plugs in that format, wrote a little bore drilling operation which just spirals down into the part, as you can see, and then made myself a stack of plugs, which was actually really helpful because I didn't have to stand at the drill press drilling them. This could just run away in the background and run them off whenever I needed them. The other good thing is that you don't have to deal with plugs that break off in a plug cutter and then having to dig them out by hand. That is a real pain, and if you've ever drilled loads of plugs, I'm sure you guys will be well aware of that process. So the frames then, once they're plugged and sanded and rounded off, they get ready for coating. Now you can see I'm using these little wood blocks here. I've got 100mm or so section of off-cut timber, hole drilled in the center of it, and then you can see I've got a stack of washers on the inside and then one washer on the outside. This just means that I can screw these to the frames and then I can stand them up as a little two-sided foot. So the stack of washers on the inside gives me clearance for my roller when I'm epoxy coating, and the length of the leg just stands that off the table so that I can clearly access both sides and I'm not going to affect the finish. These also allow me to pick the parts up and turn them over so that I can coat both sides in one operation without having to worry about a joint line. So once the parts are prepped and ready for coating, all the feet are on, we can take them upstairs, and that's where we're going to start the coating process. The bulkhead for frame 9 gets a load of little cosmetic repairs, a couple of little gaps in some of the joints between the planks that I've veneered on this frame, so just for cosmetic reasons really, I gave those little fill in and then sanded off the surface. Knock those plugs back once the epoxy is cured, and then we can sand those back as well. So when I built this bulkhead originally, I kind of did like a rough belt sanding. I don't know if you remember from the video, but I used a 40 grit belt sander just to get those veneers back nice and flat. And because they're nice thick veneers, these were 3mm veneers on either face there, we've got plenty of material to work with. So there's still a couple of little cross-grain scratching marks left over from that process, so I just wanted to run over them with the DA sander, 150 grit disc. I'm using this to prepare for epoxy, and just take out any of the cross-grain scratching, flatten down those plugs, clean up those little cosmetic fills, and generally get the bulkhead nice and clean, back to fresh wood as well, ready for the epoxy coating process. And you can just see me getting the last few remnants of marks out the timber there before we coat. Feet get installed so that we can coat this on both sides. And then we're ready to go upstairs. Okay, so then we are on to epoxy coating. I'm using the West System 105-207 resin and hardener combination for this, and I highly recommend that if you're doing any clear finishing processes. It's formulated specifically for this purpose and works really well for it. So mix your resin and hardener combination together in a mixing pot really thoroughly. Make sure the two are well blended, and then decant that as soon as possible into a large roller tray. That's just going to allow that epoxy to spread out and take up loads of surface area and prevent the heat from building up with the epoxy inside a pot. That's going to give you a lot more working time and stop things from exotherming. And then using their short pile foam rollers for this. These really are the best thing I've found for epoxy coating. They don't hold too much resin within the roller, which is exactly what you want, and they apply a nice thin film. We don't want to be putting this on too thickly because that's going to cause us problems. So roll that out onto the timber. As you can see, it's starting to bring out a really nice rich color to that bulkhead for frame 9. Now you can see I'm pretty much loading up a roller and then just doing one stripe, maybe slightly wider than the width of the roller. If you're doing any kind of finishing operation like this, I really recommend getting into a nice little repeatable routine. So remember to yourself how wide a width you lay on per loading of roller. So I'll load up the roller in the tray and then I'll roll slightly wider than one roller's width onto the surface. By doing that, it just gives me a really nice even film thickness across the whole area that I'm doing. So I roll that with the grain initially, then I come back and I go across the grain just to even that out. Then you'll remember my little tipping stick from before when we coated the stringers, if you saw that video. So we just go over that after a few minutes and re-tip the surface to start to take the tops off of some of those bubbles that might be appearing due to the air that's coming out of the wood. You can start to see the results of that book matching the grain that I did when I veneered frame 9, the bulkhead. You can see we've got a beautiful repeating pattern on that there, and now that we've started to get that coated, we can really see that grain pop in and come into life. So really nice indication. And of course, remember that this is actually the start of the finishing process for the inside of the boat. So this is effectively the kind of primer, the foundations for the varnish system. You know, we're going to have a satin finish varnish throughout the inside of the boat. The entire inside of this boat is going to be bright finished. And this is the early stages of creating that finish. We're also using this process to encapsulate the wood and to limit the moisture transfer from the atmosphere within the wood, and that's going to limit the movement of the wood, which is also going to help the longevity of the boat. But you can see with that beautiful grain there, this is also the start of the finishing process for the inside of this. So I won't be doing any staining to the inside of the boat. We're going to have some incredible contrast here between all the different woods that we're using, between the larch, the utility for all the framing and bulkheads, and the keel, some other elements like that. We've got the larch for the longitudinal timbers, the stringers and the topside battens. And then I'm going to be using yellow cedar. Some of that came through in the Sykes delivery that we had at the start of the video. So we'll be taking a look at that in a bit. And that beautiful pale white yellowy colour of the cedar against the darker utility is going to look really highly contrasted. So for that reason, I don't need to do any staining in there. We're going to have a beautiful range of colours. This is going to look really smart, the inside of this boat, once we finish the planking. So that's the first coat of epoxy applied on those parts. Just going to leave that for a little while to start to kick, and then we'll come back and do coat 2 in a bit. So let's take a look at what wood we've got in. We've got the utility down here. Now, 2 different formats that I've had Sykes do this for me here. This is going to be the bottom planking, the outer bottom planking. So we're going to do the inside with the yellow cedar, which I've put upstairs. We'll go up and take a look at that in just a minute. This will form the bottom planking. Part of what we decided upon when Andrew was here was that he said that we could actually plank the bottom of Temptress with 3 layers of planking instead of 4. So I've gone a little bit thicker with this. I've gone with 3/8 thickness, and I've had the that sawn to this. We'll take a look at the thicknesses when we get up to the cedar, but this is the stack of planks which will form the outer final layer on the bottom. This is going to be my hull side planking. Now, what I've had Sykes do here is to resaw a thicker board into 2 18mm boards. Now, the idea for that at the moment is that I'm going to cut the profiles of my side planking. So this is all outer finished side planking stock. The plan is that I will cut the profiles out of this board, and then I'll resaw it down the middle. So I'll resaw this 18 into 2 9s, or they'll probably be more like 2 7s or 8s by the time I've resawn it. And then I'll be able to open that up and book match it. So you can see that actually these boards are already book matched because Sykes have already sawn them once. So when we fold them open, you can see we get that book matched grain. But what I'll actually do is I'll do that again. So we'll end up with it sawn lengthways like that, but once I've cut the pattern of the plank out. So we'll get a perfectly matched plank grain pattern for either side of the boat. And actually, if I utilize the fact that these are already resawn, we can do kind of 4 planks that will all match, and that'll look really pretty cool. So so that's the outer layers of planking. Outer layer of the bottom of the hull, which of course will be painted, won't actually be seen, but we want it done in utility anyway, just because it's a bit more hard wearing than the cedar. And then this is the outer planking for the hull sides, possibly running over into the deck. I know it doesn't look a lot, but bear in mind that each of these boards will be cut into 2 and create 2 planks at least each. So let's hop upstairs, we'll take a look at the cedar. So here's the cedar. So we've got 2 different stacks here. We've got this, which is going to be the side planking, and then we've got this, which is going to be the bottom planking. Again, all internal layers, so this is what we'll see inside the boat. And if we grab one of those planks, I mean, you can immediately see the beautiful, clean, white grain that we get with this cedar. And then once the boat's planked, this is the kind of contrast we're going to have on the inside, which is going to be really smart indeed. Now, Sykes Timber have sawn this for me, and hopefully I can pick this up on camera, but you can see they've got this really fancy horizontal bandsaw that they use, and it gives an incredibly fine finish to the surface. This is a sawn board, it's not been machined afterwards.
and you can see that really fine texture there to the surface. Just a slight key into it, and you know, it's really flat, really even sawing down the full length of the board, which is fantastic. This finish is actually perfect for bonding to. We don't want it to be too smooth. We want a bit of roughage there for the glue to grab hold of and to get into when we plank the boat. So this is going to be absolutely perfect. And what I've done is I've got these machines slightly oversized, so I actually need 8.5mm planking for the bottom, and I've got these machined to 10. Now what that means is that I can run this through the sander and I can clean up the one internal face that you'll see within the boat, so I can get this perfectly flat. I'll take 1.5 mm off of that. That'll leave me an 8.5mm finished plank, and the sawn face will end up bonded within the planking. And then on the sides we're going to do 2 layers of 4mm diagonal planking before I do the outer. So I've got these machined to 5mm, and then I'll do the same thing. I'll smoothen off one face that will be on the inside, and then I'll use that sawn finish for all the bonded faces. So that's pretty much all the wood in now. That's all the planking. This is the stock here for the chines and for the keel, which we'll put in before too much longer, hopefully. That's all of my internal planking, bottom and sides. And then downstairs is the utility for the outer planking on the bottom and on the sides. The reason that I'm using the yellow cedar is twofold really, to get that beautiful contrast between the finished frames and the hull skins. That's going to look really sharp indeed, but mostly really to save weight. This is incredibly lightweight, the cedar, in comparison to the utility, and because utility is a little bit heavier than the original African mahogany that the boat was designed to be built with, I'm inducing a little bit of extra weight with the frame components and the components that I'm building with that. So I'm hoping to counteract that by saving a lot of weight by using this really lightweight yellow cedar. So we're going to tip the balance back in its favour weight wise, but also make it look nice in the process. So that's all the wood in, and that's what we're using it for.
Okay, so then we can get started with coat number 2. Now with coat number 2, it gets a little bit more difficult to see where you've been. As you can see here, rather than the high contrast between the uncoated wood and coat number 1, we've basically just got a glossy surface on top of a glossy surface. So it gets a little bit difficult to see what's going on. I recommend then using the practice that I mentioned previously of defining yourself a set parameter to roll onto. So I'm roughly following the width of the veneers here, so I'm using one fill of the roller on the roller tray to do about 1 veneer's width, and I'm working halfway down the board. As you can see here, I'm doing sort of top half then bottom half, and then as I get further across into the mid of the table, I just focus on the top half. I'll then do 1 long roll just to even that out between the full run, but you can see that I'm working in quite sort of regulated sections here, so that means that I just again keep that even film thickness, but also I know where I've been, and I sort of keep track of it by using basically the features within the surface there. I'll do a similar kind of thing when I'm varnishing boats. I'll use things like plug patterns or frame markings, things like that you can see in fixtures and fittings within the boat, and use that to kind of define set parameters. And as long as you're loading up the roller and then applying the same size of surface area each time, you're going to get yourself a nice even film thickness. So there's a look at the half finished bulkhead. You can see on the left hand side there is the area that I've rolled onto, and on the right hand side is the area that's still coat 1. So not a great deal of difference between the two. You can see how difficult it is to see definitively where you've been, so using that practice to monitor that's a really good idea. You can see here a very slight milky patch to the surface. Now you want to try and avoid working the epoxy too much when you apply it. These are basically micro bubbles that get built up within this epoxy as I apply it, and excess working of the surface is going to increase that. And you can just get a hint of a kind of slight hazing to the surface here. This is one of the reasons that I highly recommend using the 105-207 hardener and resin combination. This product has a slower cure time, and as I said, it's formulated specifically for clear coating. So in instances where you get this milkiness appear in the surface, it will actually release with 105-207, and those little bubbles will slowly raise to the surface and release. That is something that you might not see happen with some of the faster curing epoxies, and you can end up with leaving that milky finish in the surface, which we really don't want to be doing because we want this to be nice, clear and bright finished. On top of that, this is the reason that I work in relatively small volumes of epoxy, and you'll see how much I'm mixing up in just a minute. But by keeping regular fresh batches mixed and by working in small volumes, you keep that sort of working time relatively good. What you don't want to be doing is letting that epoxy start to get to the stage where it's starting to gel over and maybe become a bit thicker. In instances like that, that's when you're going to see this kind of milkiness in the surface stick around and not release in the correct way. But by using small batches regularly mixed up, that will greatly help with letting that milkiness and those micro bubbles release from within the finish and give you a good clear finish. Now in this section here, I'm just working this extra hard just to give you guys an illustration of exactly what that looks like in an extreme circumstance. So you can see a highlighted example here of two little sections that I've worked really hard, and you can increase that kind of milky finish. So that's what you want to avoid. Avoid any kind of agitating of the surface or rolling the surface too much and too quickly as well. That's going to increase this even further. This will release, but obviously we want to reduce it as much as possible. So once I've applied the resin, I then come in and do a roll across the grain. Nice long passes just to get that film thickness evened out and get it nicely distributed. The tipping pass is also going to help greatly with alleviating those little milky areas, and best practice I've found is actually just to let the epoxy sit for a little while, allow it to start to flow out, and those tiny little bubbles will start to raise up to the surface and release from within the epoxy. Then a little tipping pass is just going to knock the top off of those and get rid of them. But generally, providing that you've left enough working time within the epoxy, this is going to flow out and these will release. So remember to keep those mixed batches nice and small and regularly mixed up. Keep them fresh and give yourself maximum working time. You don't want to be trying to paste on thick epoxy as it's starting to set up on you. So environment is a very important factor around the epoxy coating process. What we're doing when we're encapsulating is we're locking in the moisture content that is within the wood, but we're also preventing it from transferring from the atmosphere surrounding that wood into the wood. Humidity is probably the thing that we want to monitor most closely within the workshop environment, certainly in the run up to encapsulation, but to be honest, it's good practice to do it all the time throughout the workshop anyway. And humidity is going to have quite a big effect on the moisture content of the wood. Around about a 10% change in relative air humidity is going to translate to about a 1% change in the wood moisture content level, and we want to keep that as low as possible so that when we encapsulate, we lock all that in and we prevent any movement and we get that wood nicely sealed and encapsulated and stop that moisture transfer. Obviously we don't want the wood to be too wet when that happens, otherwise we're going to potentially cause a situation of rot occurring within that encapsulation. So this little device here is something that you might have noticed in the background of the shop. So this has a readout for current temperature and relative air humidity levels as well. Most of the time I'm kind of shooting for around about 50% humidity. That can fluctuate in here, usually anything from kind of 45 to maybe up to 60 sometimes, but generally I keep that regulated pretty well. It's a fairly small workshop this, and so managing that that environment is actually pretty good, and that is all due to my heat system. So we'll go over and take a look at what that is. This is the heating system that I run in the workshop. So this is a heat pump. You know, basically it's like an air conditioning system really. It draws air
in through the sides here, and you can see there's filter panels, and in behind there we've got the big kind of refrigerant plates. And then, so there's an inlet on either side, and then there's an outlet on the front, and then there's this big tube that runs through and to outside. So basically what this machine does, this does all of the heating for the entire workshop space, and it does it very efficiently. Actually, we used to use storage heaters here, which you can see over there. They offer very little regulation. They're basically either on or off, and they cost an absolute fortune to run. This actually only uses 1.8 kilowatts of electricity, so it's really efficient for the size of space. Those storage heaters are probably 3 kilowatts each, and they're dotted all the way around the shop and upstairs as well. So there's a lot of them. When we turn those on in the winter, that costs us an absolute fortune. This is a much better solution. So this runs on about 1.8 kilowatts of power, and we've got all kinds of climate control stuff here. We can set the temperature up and down, and we can do different modes. So basically what this does is it pulls in air through here, and then it goes around some stuff inside. I'm not entirely sure exactly how it works, but basically it separates the air that comes in into hot or cold. So when you're on heating mode, you get hot air come out of here and warms up the shop, and you get cold air go out of there. When you've got it in air conditioning mode, it does that in reverse. So you get cold air come out of there, and you get hot air come out of there. But what it can also do as a byproduct of that is dehumidification. So you see this little pipe that runs into a drain here. That can actually just strip moisture out the air, so you can run it entirely on dehumidification mode, and that is going to make sure that we keep that relative air humidity nice and under control. So most of the time, to be honest, this just sits on auto. I just set a temperature and it just kicks in and out as and when it needs to. As you can see, chucks air out of there, and if we're on heating, we get warm air and cold air through there. So that's something that I installed in the workshop a few months ago, just around about the start of the year, for a number of reasons really. Primarily to save cost on the heating. If you guys are watching from outside of the UK, you may not be aware, but in the UK just recently, our electricity and energy prices have gone absolutely through the roof, and we now officially have the most expensive electricity of any country in the world. And when you're running a workshop like this that has electric storage heating, that is incredibly expensive. Our electricity bill on those storage heaters for January alone was £800 for the month, so really costly. So getting that heat pump in was about making that much more efficient, bringing the cost of heating this place down, but also primarily a conscious move in the run up to the encapsulation on Temptress was about just getting the environment here in a much better state and making sure that it's nice and dry and at the correct temperature. So that's some things to consider in the run up to encapsulation. Make sure that your temperature and more importantly your humidity levels are well under control, nice and stable, and that's going to keep that wood at a nice stable moisture content as well. We're aiming really for ideally sort of 10% in the timber. Anything less than that's good. 12 would probably be the upper limit. We wouldn't want to be any damper than that really before encapsulation. So generally keep it dry as possible before we encapsulate.
So let's take a look at the mixing process. Mixing by weight is by far the most accurate, and I just find it quick and easy. It's really good if you're refilling a cup that's already got epoxy in it as well. It accounts for that little bit being in the bottom there. So put that mixing cup onto a set of scales and zero those scales off. Then you can pour in your resin. So as I mentioned, West System 105 resin here, and I'm mixing generally about 200 to 250 grams of resin at a time here. So as I said, working in quite small volumes, certainly given the surface area of that bulkhead. Then get yourself a calculator. Enter the exact weight of the resin into the calculator and divide that by 3.5. Then add that weight of the resin back on again, and this will give you the total weight of the resin and the hardener combined. This is a 3.5 to 1 mix ratio when done by weight, so that's the reason that we divide by 3.5. Pour in the hardener up to this total combined figure on the scales, and then you're ready to thoroughly blend the two together. Now, nice long rigid mixing stick is really good for this, and as you initially start to see the resin and hardener combine, the product will turn milky and cloudy, but as the two become fully blended, it goes back to a crystal clear finish. So give this a really good stir. A couple of minutes, to be honest, is probably my normal mixing time for this, and scrape around the outside of the pot just to make sure that none of that resin product that went in there first is stuck up around the edge and unblended. Once we're done mixing, as I mentioned, get that out into a large flat roller tray as quickly as possible to distribute that resin, give it plenty of surface area and prevent it heating up and exotherming within the pot. As the temperature increases, the rate of cure increases as well, so that's the reason that we want to prevent heat buildup within this being in a small confined space. As you can see, turning over a full-scale bulkhead with sticky clear coat epoxy on both faces is a little bit of a tricky task, even with those little tabs on there, and I did almost drop this, to be honest, but very slowly managed to get it round into place, and I only ended up with one section of sticky epoxy on my arm, so that wasn't too bad going. Now, finish wise, you might think that it doesn't look the best, this finish at the moment, but consider that we are very early on in the finishing process here. We're around about the equivalent of coat 4 to 6 really if you were varnishing this. And of course we're finishing over bare wood, but we're doing that with a very thick product. The epoxy is far thicker than varnish, so we're picking up dust out of that bare wood. We're also doing this in a fairly dusty environment. And because I'm coating over existing epoxy, we're doing that on a very sticky surface, so we're recoating on top of something that is basically the equivalent of sellotape tacky levels. So you're going to get dust in the finish at this stage. We're going to get a few bubbles as well as the epoxy replaces the air that is in the wood grain. That causes those gases or air to be released out of the wood as they're replaced with epoxy, and that's what forms the bubbles in the surface. In order to try and minimize that, we really want to try and apply this as temperatures cool. What we don't want is to apply the epoxy and then increase the temperature. An increase in temperature means that there is more air or gases coming out of the wood, and they're going to get trapped within this epoxy coating. What we ideally want to do is to warm up the environment before we start coating, and then allow that to slowly reduce post application. That's going to have the opposite effect of actually drawing the epoxy into the surface and limit the amount of bubbles that we see in the finish. There are still going to be some, of course, but as we go over with consecutive coats and do that tipping passes, we're going to aim to burst those bubbles and improve the quality of the finish. But if you're doing this process, don't stress too much about the quality of the finish at this stage. Remember that this is very early on in the finishing process, and we're not looking for a perfect flat glossy finish right now. What we're looking to really do is to fill that wood grain and begin encapsulating the timber. When we get to the later stages of finishing, where we do a bit more build up of volume on the surface and we do some finer finishing, that's when we're going to get things really nice and flat and looking perfect. So there's a look at the epoxy encapsulation process, a little bit of an insight into why we're actually doing that, and some tips on achieving it as well with a good finish. There's loads of this work to do, as I've mentioned previously on the boat. There's going to be quite a few of these videos, so that's a little insight into that. The next one, I'm not entirely sure what I'm going to talk about in the next video yet. I thought maybe about doing a live stream, and perhaps we can do a kind of Q&A at the same time, as I did a live stream on building the frames before. So maybe a live stream epoxy coating might be a good one, and you guys can just kind of fire questions at me if you want to do a general Q&A about all things boat building. Then perhaps we could do that. Let me know in the comments below if you guys would like to see that for the next one. Just a reminder that should you wish to build one of these boats yourself, we do sell the plans for digital downloads, so you can download them, take them to pretty much any CNC shop in the land and get yourself a kit of parts cut to make one of these boats yourself, either full size or a
quarter scale model version if you'd rather do something a bit more simple and on a slightly more friendly budget. I'll put the link below this video if you would like to have a look at the plans for this boat. I want to say a huge thank you to everybody who watched the previous video on costings. That was a very difficult one for me to put together, but I'm really pleased that it was so well received. I really appreciate all the positive comments that you guys put below. I do read all of the comments. Unfortunately, I'm not in a position where I can always respond to all of them now because of time is just kind of running away with me, so apologies if I didn't get to respond to you, but really appreciate them anyway. And I greatly appreciate the new influx of patrons that are helping to support this project. Massively appreciate that. It's really helping to move it on, so thank you to you guys for coming on board with that. If you'd like to offer some additional support to the project, then by all means check out Patreon. Failing that, just keep watching the videos, and I greatly appreciate that as well. So hope you've enjoyed this one. Let's think about what we'll do in the next one, maybe like a live stream or something whilst I do some more coating. So cool, catch you guys in the next one. Cheers.